Um, Hi everyone, welcome back to Geeks for Geeks. This is me, Yash Dwivedi. So today we have another DSA mock interview. Our guest for today is Jagreet. So we'll be interviewing him for this DSA round. I'll be asking him two or three questions in a span of 45 minutes to 1 hour. So all of you can just quickly give me a +1 in the chat and hit the like button if my voice is clearly audible to all of you so that we can get started with the video. So just quickly hit the like button, guys, and give me a +1 if my voice is clearly audible and there is no problem with that, so that I can call our guest for today. Is it fine? Great. So now let me call Jagreet for the interview. Hi Jagreet, can you please introduce yourself?
Hello everyone. My name is Jagreet Das Gupta. I'm currently in my final year BTech at IM Kolkata. So I've been doing competitive coding for a while now, and I'm rated 5-star on CodeShip as well as qualified for ICPC regionals since last year. But recently I moved on to Android and backend development. So yeah, that's about myself.
Okay. So are you excited for this interview?
Yeah, definitely.
How much you rate yourself on a scale of 10 in DSA?
I'd say about 8.
Okay. So 1 second, in the private chat, I will share with you a Google Doc link. Just give me a second. Okay. So you can see in the private chat, I have just pasted a Google Doc link with you. Can you just open it quickly and share your screen at the same time?
Sure.
You will find the link, like you will find the share option there on there. Fine.
Is it visible?
Yeah, perfect. It's visible.
Okay, cool.
I hope that it's visible to the audience as well. So let us start with the first problem itself. So the first problem says that you will be you like can you just like there's some background noise. So can you just uh, close the windows if it is possible?
Which one? Okay. Oh.
He will be joining in some time. There was some noise issues, so that's why he's trying to join again. Till then, all of you can tell me how much excited you are for this interview, guys. Okay.
Is it fine now?
Yeah, Jagreet, can you share your screen?
Yeah. Uh, is it okay now?
Yeah, looking perfect, perfect.
Okay.
So the first problem that we'll be doing, so I'll give you an array, okay? I'll give you an array which will be an integer array. It will consist of n different elements, and the ith element will denote the number of characters in one word. Okay, so ith element of the array, like every element of the array will denote the length of the word. Okay, so ith element will denote the length of the ith word, and I will give you a limit k. Okay, the limit k will be the number of characters that you can put in one line. The limit k is the number of characters that you can put in one line. So, like, you must like, have you ever heard about word break, Jagreet? Have you ever
Yeah,
heard
I
about
have heard. I
what
have.
happens with word break is, if let's say you are typing something on, let's say something like Google Docs, or let's say something like Microsoft Word. So if you type something and that if the spaces that are there, if the number of characters allocated for that particular line, if you exceed it, so it does not happen that you write some of the like a particular word is there, a larger word is there, so you do not write some characters on the upper and some characters on the next line. You do not do that. Okay, the complete word comes in the next line, right? You must have observed this thing. So this is what I'm saying, that if I allocate k characters, so it is important to notice that every character that will, like every word that will be given to you, it will be of less, if its length will be lesser equal to k only. Okay, there will be no word whose length is greater than k, because I want to accommodate each of the words. Okay, so what your task is to minimize the cost. Like assume, like you have to assume that the length of each word is smaller than the line width. So when the line breaks are inserted, so if let's say you place a particular ith word. Okay, if let's say you place a word which is of length 3, so after that you must be having some spaces. Okay, so after you place it, so you will take one space, correct? You will take one space, and then you will try to place the next word. So what you have to tell is, like, let me give you an example for this. let's say, can you just scroll down a bit where I'm
This.
writing the example?
Okay.
Yeah,
Okay.
there
Yeah.
only. Perfect, perfect. So what I'm saying is, let's say I give you k is equal to 6. Okay, so this means that I'll give you 6 spaces, right? 6 blank spaces. Like if you will see here, so I'll give you 6 spaces. Let's say. Okay, so 1, 2, 3, 4, 5, and 6. Okay, I'll give you 6 spaces. And what I will give you is I'll give you the words. So let's say I give you a word of length 3. Then I give you like let's see the example for that case once again. If I give you the words like 3, 2, 2, and 5. Okay, 3, 2, 2, and 5. So first of all, I'll give you a word of length 3. Then I'll give you another word which is of length 2. Then I'll give you another word which is of length 2. Then I'll give you another word like first of all length of word 3, then 2, then 2, and then 5. So k is equal to 6. So notice every line there are 6 words, 6 spaces. So let's say the first word was, let's say, GFG. Okay, so there are 6 spaces in this line. So initially, let's say you put GFG here. Okay, if you put G, F, and G here. Okay, suppose GFG was there and you have put GFG. After that, you still have how many spaces remaining, Jagreet?
3.
3 spaces are remaining. Okay. So can you put the next word? Let's say the next word is of length 2. So can you put the next word
Yeah, we
in
can.
this line?
We
You
can.
can, right? You can, right? If let's say it was CP or something, so you can. Or maybe if you want, you don't. So if you don't put, let's say you don't put, let's say you put next word, let's say CP or something in the next line. So in that case, 3 spaces are wasted. Okay, 3 spaces are wasted. So the cost for that would be 9. Okay, you are getting this part?
9. Sorry, let me just.
Yeah, so
6 plus
basically the number
6.
of, yeah, basically
How
it's
is it
nothing but 3
9?
into
Is it
3.
3 into.
3 spaces
Okay,
are
so
remaining, the number of spaces into the number of spaces.
can you like formalize the cost is calculated out again?
I'm saying that if you waste some of the words, some of the spaces in the previous
Right.
line, if you have
Right.
wasted, like if you put CP in the next line, that means you have wasted some of the spaces. In
3
that case, it
spaces.
would be 3 cross 3. Okay.
Okay,
Now
so
let's suppose
basically
that,
the square of the number of spaces wasted.
yes. So if you see for this word, let's say if I wrote CP here only. So
Right.
will you write CP adjacent to GFG? No, no. You will
No.
take one space, yes or no? Otherwise,
Yeah.
you will not be able to differentiate between the words. So that
Right.
means total 6. Suppose I uh, asked you for 6 spaces. So one space you will take more. Why? Because you want to keep a gap between the characters. Then you will have CP. Okay. Now, is there any space left in this line?
No.
No, because 3 characters you have used there, one space, and then 2 characters for C and then P. So
Yeah.
I can say that no space is left. So 0 into 0 will be nothing but 0 here. Okay. This
Got
can
it.
be the
Got it.
case.
Got it.
Let's say the next word 2 is there. So what I could do with 2 is, let's say if it was 2. So let's say it was something like, let's say if it was go, something like go. Okay. So I can choose, like if I put go, so now I'll have 4 more spaces. So if I have 4 more spaces, so can I put the word coder down there?
No, you
No.
cannot.
Why?
No,
Because the word
because
wrap,
yeah.
because
So
I,
we have to.
I if because only like character length, the next, let's say the next word of 5 characters is coder. Okay,
Right.
CODER, which has 5 words. So I just have 4 spaces remaining, so I cannot put it. Okay, basically
Right. Right.
I can see 4 spaces, but actually the number of working spaces for me are nothing but 3 now, because I'll take
Right.
one more space as well. Okay,
Yeah.
so that means, suppose that if I waste this thing, so how much will the cost be? Can you tell me? 16,
Uh, s-
4 into 4.
4 into 4. Right. So we are also
Okay,
calculating the space which we wanted to take into the number of spaces wasted.
no,
Right.
no, no. Like here, if I'll see on the upper side, so if you take a space to differentiate between two
So we're
characters, so
not
that will not
including
be
that.
counted. We are not including that. Okay.
Okay. Got it. Got it.
Then if you see, let's say if I put coder, okay, so you will say that, okay, one space is left after coder,
Yeah.
correct?
Yeah.
Uh, because the word with the length 5 was coder. So if there is still a space remaining, okay, if there is still a space remaining, so in that case, uh,
So I think we are going to take.
if
This is.
like there's a lot of noise from your end.
Sorry.
I'm not
Just.
sure whether you have closed the windows or not.
Is it fine now?
Yeah, seems fine now. Okay. So you see, after this, if I have the word coder, okay, so you will say that, okay, now 1 into 1 will be there cost.
No, because we are not wasting any spaces since that space would be
Yeah,
like
because if this is the last word, then you are not wasting any space. So the after placing the last word, you will have zeros into zero cost, no matter how
got it,
many spaces are left in the last line. Okay.
got it,
So
got
for
it, got
this,
it.
I can see that the cost that I'm paying is 16, but there can be a better combination for that. Okay. The better combination is that one, like if I will tell you about the better combination. So what I could have instead done is there can be many combinations that I can have. But suppose what I could have done is, let's say I have a space here, space here, space here. Okay. So that would be 3 into 3, correct? If
Right,
I do not place the word with length 2 there, let's say I put CP here, and then I take one space more, and after that, let us say that I put the word go, okay, which is of length 2. After that, one more space. So that means total one space is just wasted in this line, yes or no? Correct?
right,
So it would be 1 into 1. So after that, I will place coder, and the moment I place coder, so one space is left. But for the last line, no, like after placing the last word, I'll not count the number of spaces left because my words are placed. Okay, so actually there will be no spaces. So 0 into
got
0,
it,
so the total cost comes out to be what, 10.
got it. Yeah.
Okay, and this
So
is the
this
minimal
is
cost for this.
okay.
For there can be many permutations and combinations, right? You can understand. Either you keep it in the same line or next line, or there can be many. So
Right.
what you have to do is you have to minimize the cost. Understood the question?
Okay. Got it. So
Okay,
one
so
thing, can we rearrange the words? Like,
no,
can we
you
go?
have to
Okay.
like no, you cannot rearrange the words. You have to take the words in their order only, in the order in which they are given in the array. So basically, you
Okay.
will not be given the words as well. I have just taken the words for your for explaining you. You will just be given the length of the words.
Okay. Got it. So is there any time constraint given in the question?
You can think of any approach for now. Then we can try to optimize it.
Okay. Got it.
If the audience is
So
also clear, then they can hit the like button and they can give us a quick +1 in the chat. Yeah, go ahead, Jagreet.
so I'm writing down here. So let's say we have some words like ABC and a word AB and a word ABC. So, and let's say we have the space length of 5. Let's say. So we can put ABCD here for one, and one space will be left. So can we do like this? Can we omit the entire line like this and move on to the next line itself? Although that won't be optimal. Can we do that?
You can do that, but
Okay.
that doesn't seem to be optimal. You can, if you
Yes,
want,
yes.
you can do
I'm
that.
just exploring my options. Okay, got it. So another thing we can do is we have to put ABCD since that would be the most optimal approach. And there's one space left. So we put AB in the next line. Now I don't think this space would be counted in the cost because we have to use one space anyways.
But don't you think you have left one space, right, for that particular line? So
The
that will
space
be
is
counted.
this will be counted.
Yeah, that will also be counted.
Also, if I had another word something like this AB here, then it won't be counted.
No, it won't be counted.
So mid space would only be counted if it has a word after that, right?
Mid space, if there are two different words and you want to differentiate them, so you are taking one space, so that will not be considered. But after
Okay.
placing, after placing, if you move to the next line, then whatever spaces are left in the previous line, they will be counted for sure.
Okay. So basically, we can put one space and say that this space would be counted in the cost only if there is a word after that in the current line. We can
Okay.
formulate this, and if there is no word after that, then we don't count the spaces. So the most brute force approach would be to like first place the first word in the first line, like ABCD here, and then we have to check can we put the next word here or not. If we can, then we put, or we don't. Okay, so let's say here it was 5, but let's say we have something like 6. Okay, so we make a choice here. We either place ABCD here, the AB here, or we don't. There are two conditions. If we don't, then we are wasting 3 spaces, and that's fine. Then we move on to the next condition. Now here our counter is here. Now we put ABC here, and since the word is complete, there is only one space. There is no space wasted here. And if we put ABCD here in the next example, sorry, then there are 3 spaces wasted. So the most optimal approach would be this. So we basically explore all the options, like putting the word either after putting each word, we check if we can place the next word or not. If we can, then we put the next word or we move on to the next line. Now, if there is a suppose ABCD, here you can put the next word, right? AB. Now, if we can put the next word, we like move it in two different directions. In one case, we put AB here. In one case, we don't. And then we recursively put it, search it again using the next word. So that's the most fruitful solution.
So you're thinking about a greedy solution.
No, greedy would be that if we can put the next word, then we will put. But in this case, I'm exploring all the options. Even if we can put the next word, I'm going to like explore a case where we don't put this AB here. For example, here we
Okay.
can put AB, right? In greedy, what would you do? In greedy, we would put AB and move on to the next line. But here, we would one case we would put AB and one case we won't put AB, like this.
Correct.
Got it? So
Okay.
this approach doesn't seem to be the most optimal one. So what we can do is we can use dynamic programming to like optimize this. For example, if we have a sub problem, like suppose we begin a word AB here, doesn't matter the example here. Suppose we have a
You
word
can take the
AB.
example that I've taken: GFG, CP,
Okay,
Go,
got it,
and
got it,
Go.
got it. Suppose in
The
the
K is
third
equal to
line,
6 for that. Yeah.
suppose in the third line, I don't know what the upper two lines have, but suppose in the third line we go with CP. Okay, CP, and then with the first word we have to put is CP. Then no, not CP. Suppose we have Go here. Okay, suppose with the first word we put in the third line is Go, and let's say second line and first line we don't know what it is for now. Go. Now the number of spaces remaining is space, space, space. Three spaces remaining. And suppose we
Four
have explored
spaces.
this condition. Sorry. Oh, sorry,
Four
four
spaces.
spaces. Right, four spaces. So this is one like suppose this is a situation we come across and we explored this. Okay. Now, what are the upper two cases that can be? We can either put CP here and go for four spaces here, and we can put GFG on the top and have three spaces. This is one condition. But you can also put CP down here and entirely skip the second line. Both these conditions would result in this problem, right? So we are seeing we are having a optimal approach where we can like use this problem again to compute this, so we don't have to like again and again compute this third line where we put Go in the first the word. So that way we can optimize the approach using the dynamic programming.
Okay. So, would you like to write the code for it?
Sure.
Okay,
So
1 second. So what I would do is, give me a second. If you will look at the private chat. So I've just shared the problem link. Can you open the editor for the problem link? Yeah, you can quickly sign in.
this is okay.
Yeah, you can open the editor. You can do the full screen. Before that, maybe you can set the ID as dark so that everyone can clearly see that. So you can set it to Dracula, the theme to Dracula, so that no one has any complaints regarding the visibility. Themes. You can go to the themes part.
Yeah, I'm just
Just mark it as Dracula so that it's visible to others.
okay, draft.
Yeah.
Okay,
Okay.
great.
You can
Or
do the full screen.
should I increase the font size so it's more visible?
No, you can just do the full screen.
Okay, just let me just check the examples once. Uh, got it. Okay. So we are given an integer of numbers and a vector of integers and decay. Got it.
Like you will be
All right.
given the length of the integers, like length of every word, not the exact word. The words we are taken just for example,
Okay. So
and you'll be given
let's
the number of characters that you can place in a particular line. Yeah, go ahead.
define one variable as word index, and it would there's some echo coming. Can you fix that?
There's no echo from my side, but still I'll mute myself.
Uh, yeah, it's fine now. So let's say the first index is 0. So let's take an example here. So right now, suppose we have the index here, word index, let's generate by WR. So we are going to increment this one by one and check for each word. And we're also going to keep account of the line number, which we're currently on. Line number. And that's also currently 0. So let's say we have a function like calculate, where we pass in the current word which you want to input and the line number, and also the current, like which character it currently is. So let's say it's K, then let's say it's at character number yeah, let's say it's at character C index, character index 0. So initially it's at the first of the line, and we're also going to pass it here, this index, and also going to pass it nums and K. And this this will return us the optimal approach which we want for this answer question. Let's store it in answer, and we can just return this. Now let's write this calculate function.
Okay, so basically what you have done is you have the starting, you are starting from the zeroth word, correct? So there is no echo
Right.
problem, right? I hope that there is no
No,
echo
no, no,
problem.
no, it's fine.
Okay, so you are starting from the zeroth word. As we said, you have to take this sequence according to which the words are given. The first of all, the first word, second word, and like that. You have to place them like that. Then you are also on the line number. I don't know why you have
Right.
taken this. Maybe you are
Line number is
considering
currently
line number like
the
that.
current. Yeah.
But do you think that's important for you?
Um. Let's say if it feels redundant, I'll remove that later.
Okay,
For
okay.
now, I just want, like, for clarity, I've taken it.
And you have the C end is you have taken for.
The character it currently is on the current line. So for now, it's on the first character. So I would move. Suppose we have an include a word which is of character length 3. So it will
Okay.
move on to 0 plus 3 3 at that. Okay. So the first variable is word index. Next variable is line number. Third variable is C index.
Guys, meanwhile, Jagreet is coding, so all of you can hit the like button. Okay, make sure to hit the like button if you like the question, and you can tell us like your approaches as well. I'm looking at the comments. Some people have suggested a few things. Like Vivek is whatever Vivek has suggested, that is also good. And congratulations to Ankit as well. But make sure to hit the like button, guys.
Okay. So
So
let's say
you will
we
be
don't.
writing a possibly recursive function, correct?
Yeah, yeah, yeah. So it doesn't matter, like one thing I forgot to clarify, like even if we achieve the minimal cost using suppose 100 lines, like it would be considered minimal if we will even write it suppose we have a solution which uses 100 lines but generates a cost of, let's say, 5, and we have a solution which has 50 lines but generates a cost of 10. So in this case we would consider this first one, right?
Okay.
I'm asking, like, is it the right approach?
What
Like,
what are you
are we going
asking?
to consider? Suppose we have two solutions based on this current. Let's say the first solution uses 100 lines and has a cost of 5. Okay. And the second solution has 50 lines and has a cost of 10. So we would include the first answer, right?
You
Which has
have
a
to
cost of
minimize
10.
the cost. Basically, you have to
Right.
minimize the
Got it.
cost.
Got it. Got it. So then we don't need the line number since the line number is irrelevant for us. So right now we are going to check. So if, like, currently we are going to pass C index is the first index from which we can start inputting the word. So if we are including a word and then passing on to the next recursive function, then we are also including the C plus 1 because we are also including the space for that. So let's say the current index we can write is C index, right? We're going to check the current length of the word is nums of word index. And the possible ending point of this index would be end point would be c index plus len. Let me just make sure this is correct. So let's say we have already included 0, 1, 2, first 3, and we are writing 3 is the space, and we're starting at 4 index. Let's say the word length is 3, then we include 4, 5, and 6. So it would be ending at 6. Now we have to make sure that 6 is less than equals to k. So we check if k is less than equals to endpoint. That means we can write this line here.
That
If
means
we
you
can
can
write this,
include this word in the same line.
yes, that's right. So if we can include this, then we also check like is it just let me make sure. Mm, okay, got it. Let's also include a cost for, like currently it's 0, but it will denote the number of spaces we have wasted, or currently the number of like wasted you have done, the cost which we are including in this current iteration. So let's say it's less than endpoint, then the cost would be 0 since we are not including anything. And let's say the minimal cost for the recursive function is, for now, let's say -1. So we include minimal cost equals to minimum of minimal cost, comma, calculate. The word index would be, we'd increase by 1, and the c index would be currently at len, and len plus 1 since we're including one space, and plus 1 since we're inputting on the next line. So it would be len plus 2, and we pass in nums. Also we can make this constant since we're not modifying this. We're passing k. So this would be if we include this current word. Now
Okay.
exclusion doesn't have any condition since we can exclude no matter how many times, and this would then again minimize this against minimum cost, calculate. Now since in this case we are not including this word, we're going to pass in the same word again, but since for some reason we are not including, then we pass in c index as 0 since we're moving on to the next line. 0, and for here we are going to nums and k. So here the cost incurred in this current line would be 0 since we are not minimizing any spaces, but for in this case it calculate the number of spaces currently wasted. And what would be that? Let's say we are currently on this index. Let's say 0, 1, 2, 3. Suppose we are going to be writing on the fourth index and we don't decide to write for some reason. We move on to the next line. So we are currently wasting, suppose this is index is 3 and the total length of k is suppose 6. So then we're wasting 3 spaces, that is k minus index. So the cost would be, if we don't include, would be k minus c index, and here we would just add it to this current cost, the zip cost. Now we find the current main cost here, and then we just return it.
Are you sure that you are calculating the cost correctly when you are leaving?
Sorry.
If suppose 3 spaces were left, right?
Yeah.
So
Right.
you are adding 3 to the cost.
The cost is currently k minus c index. So 3 spaces were left, right? So we are moving on to the next line. That means all the number of spaces which we are currently like present in this current line would all be. Oh, sorry. This would be into cost.
Yeah. So basically, cost is like the number of spaces in the number of spaces will be the cost for that particular line when you are leaving that much number of words.
Yeah, this is cost into cost. Okay, fine. So yeah, this looks good. So this is the brute force approach. Now, can I run the code to make sure if
Yes,
there's any
you can.
errors?
You can.
Okay, got it. Let's see if okay, so Okay, time exception segmentation fault. I think okay, I'm not including the base condition. If word index is also right here and the end equals length, we're gonna check if this is more than equals to n, then they were going running into the base condition, and then we'll return 0 since no cost
Will
is
you ever
entered.
go more than n?
We don't, but okay, fine, I'll take it 0. So okay, would it be 0 this here? Let me check. Let's work in this current line and 3 spaces are remaining, but we run out of words, so these spaces would not be included. Yeah, so this is 0. Okay, let's see. Okay, this is size. Okay, we are again running into the segmentation fault. Fine. So this we're including here word index is 0. 0.
Guys, all of you can make sure to hit the like button, okay? Because I can see the number of people watching and the number of likes are less. Can you think about it, like where you might have made some mistakes?
Yeah, segmentation fault means I'm wrongly indexing a current array. So the only array here is vector nums. The only time I'm indexing it is here. Yeah, this looks like it.
Okay.
So word index cannot be less than n. It is good. So like, can I print
You are,
some debug statements? Am I allowed to
if
do
you
that?
want, you can. You can.
Okay, got it.
But one mistake that you're making, I think, is that in the min cost, after the if statement, you have not passed the word index plus one, I think. Because if you have processed the particular word, then you are moving to the next line.
Yes, I have put in word index plus 1 here.
In the next part, min cost.
Here
One
I'm not
second.
including this current. Okay, so it's going running into infinite loop. Got it, got it.
Understood?
Yeah. So it's basically checking the same condition again and again. It
Yeah.
somehow. So we're only going to check this min cost if this index is not already 0. Like if it's already 0, we're just keeping a line. It's not more than 0, then only we can make this statement. Let's see now. Okay, so it's 10. Got it. Let me just remove this. It's -1. Okay. Major maxing. So we're minimizing
Yeah,
this.
basically.
Yeah. Okay, so it's not considering any values. Fine. Min cost.
Maybe you could have thought a little bit more before writing the code.
Yeah. Okay, so it's going to the first condition. Okay, so it's not considering any other checks. A
things in terms of basics, right? For every ith word that you are at, okay. So you don't know exactly the word, right? You do not know the characters, right? But it does not matter. You know the length of this word. So you have choices, right?
Okay. So
I think
this
your
is,
output is less now. No?
yeah, now what is, so this is
What have you written? Like you have written, okay. This. So let's say if you are remaining in the same line, then from where you start, are you taking the spaces that are required to take?
yes, like, suppose, let me just minimize this. Okay, I cannot track this out. Word index is +1, length is +2. Okay, so it's currently on word 4. Okay, so it's not including any words. Got it. So endpoint is index plus len. Len is nums.word.length. The first word length is 3, and 3 plus here endpoint is basically index is past 3. Okay, so this condition should be triggered, but for some reason it's not getting triggered. So put endpoint as well as key. So for the first index, the endpoint is less than this. Okay, so this condition is getting triggered, but word index is not increasing. Okay, we're not including any index +1. Okay, so I don't think I need to put it in here.
So basically, why do you think that it's failing? You have any idea? Like, why do you think that you are getting a lesser output compared to the expected?
I think it's not calculating this current spaces correctly for some reason. And just make sure that every condition is being checked once or twice. 3 comma 0, 3 comma 0. Okay, so it's word index. Where does it correct? Okay, so first it's 0, then it moves on to the next, skips,
Okay,
includes
so
the first word.
maybe we can try it on later if we have time. But since we are falling short of time, so can you quickly move to the docs?
Okay,
Let's move to the next question. So you can just open the docs again,
yeah,
just the Google Docs.
okay.
Yeah, right. Scroll down a bit. Yeah, so yeah, right, this one. So let's quickly have a look at this one. So it says that I'll give you an array, okay? Let me change the
Right.
color once. So basically, the problem is that I'll give you an array of words, okay? Again, I'll give you an array of words. So here it will consist of words actually. So I'll give you a vector or a list that will consist of some strings. So you have to find what? You have to find all the shortest unique prefixes to represent each word in the given array, okay? What you
Got
have
it.
to do is you have to find all the shortest unique prefixes to represent each word in the given array. Assume that no word is prefix of another. So let's say if I talk about a word like zebra, okay, can you see the word zebra there?
Yeah, I can see.
You can see that, right? So if I see it with just z, if I
Yeah,
take if the smallest prefix like that I can take, prefix is the starting part of the string, right? So from the zeroth index, so if I see, if I can I represent zebra with z, is z contained in any other string? No. So
right.
I can represent zebra with Z, correct? Now, if I see dog, so can I represent dog with D? What do you think?
Yes, I can. No,
No.
dog with the
If I
DO.
represent
Yeah.
if I represent dog with D, then duck also starts with D and dove also starts with D. So can I represent dog with DO?
No, dove also starts with DO.
Why? Because if I
Dove
represent
also.
dog with do, then dove also starts with do. So there will be a conflict. There will be a confusion for me, right? So it will not be unique anymore. Can I represent a dog with dog? Definitely yes. Okay. So the
Right.
shortest unique prefix that I can take for dog is dog only.
Yeah.
If I talk about duck, so can I represent duck with d?
Uh, Duck with no.
No, you cannot. Right? You cannot.
Yeah.
Possibly cannot. But can I represent duck? Why? Because three different strings are there: dog, duck, and dove, which starts with d. So there will be a conflict for me. But can I represent uniquely the duck with the prefix?
Yeah, I can.
Can I represent the like is my voice audible?
Yeah, your voice is audible. You can
Okay.
represent duck with du.
Yeah, right. Because it is not like du is not the starting of any prefix, right? Any other string. Now, if I talk about dove, so can I represent duck with dove with d? No.
No.
Can I represent it with do?
Dove with no.
Why? Because dog is the same. Do comes in dog as well. So there will be conflict. So it's not unique. So I can represent dove with dov. Correct?
Right.
Getting this example?
Got it.
So you for every word that I've given in the string, you have to represent it using a unique prefix, shortest unique prefix. You have to print, you have to return in a vector or a list. You have to return for every word. You have to return the shortest unique prefix for that particular word. That is what you have to do. If the audience
Got it.
has understood this question, they can write a +1 in the chat or clear in the chat and hit the like button. And Jagreet, you have understood this question also.
Yeah.
So what do you think? What can you apply here?
So the first thing that comes to my mind is using a try to like represent this all the strings initially, and then keeping a counter of the number of words that are currently existing under the current node, and we'll just after the build the try, we could going to traverse the words again one by one again through each character, and in each node we're going to find if the number of words currently existing beneath that node is one or not. Like if it is more than one, then more than one words are existing, so we go down by one level, and as soon as we reach one, we return the current string which you just formed as the longest prefix, the shortest prefix. Sorry.
Okay, so you're saying that you will use the try data structure for this.
Yeah,
Can you try to write the code for it?
sure. Can you like
One
provide me
second.
the link?
1 second. I'll provide you the link as well. 1 second. Okay. You can see in the private chat. I've just provided you the link. I hope that
Yeah.
it works. Perfect.
So okay. First I'll code the try.
You can also keep telling me about like tries. What are tries and why they are used?
Should I explain what a try is again?
While you are writing the code for it, you can just
Okay.
explain like what are tries, and while you
So
are writing, so you can explain that okay, why you are taking this and this.
got it. So try first of all holds each node of try holds the current number of like basically tree which holds the current number of the suffixes after this current node which are formed. So it basically keeps a track of all the current characters which is explored till now. So that would be next 26 is that 26. Oh, one thing I forgot to make sure, these are only going to consist of lowercase
Yes.
characters, right?
Yes.
Got it. And you're also going to keep a boolean EOF which denotes the end of string. There's a try node. It's and let's say initially we point all the pointers of this next array to null. And here is also false. I'm going to have a function word set EOF.
Can you tell me some uses of tries in real life?
So tries to
Any
store
real life uses?
like to store strings in an efficient manner such that the lookup time is linear, but the
Okay,
space is
so let's say when I ask you that, can you tell me a real life implementation of data structure like stacks? So can you tell me that?
uh, it's used like stood, like for example we are storing dishes on top of one another, like that's an example of a stack. We retrieve the first dish first, which
No,
is on top.
real life coded example where we
Oh,
use in
real
day
life
to day
coded
life.
example. Stack. For example, when we're writing a code and we need to delete the last written character, we use the backspace uses stack to remove the last written character.
Okay, so let's say if I have to talk, let's say about this thing, when I talk about graphs. So
Yeah.
can you tell me in real life where are graphs used or some algorithms of graph? Shortest path.
For
They're used in real
GPS,
applications, right?
GPS, right?
Like a company like Uber or other, they use the shortest path thing, right? Amazon and others in various ways, right? Yes or no? Correct.
Yeah.
So like you also have the tree. So why do you use tree? So because in the inbuilt your memory, the folders and everything, like it is kind of a tree based structure, right? Many of the
Right.
times, right? So I'm asking, what is the real life use case of try? Have you ever heard about it? Any
I have
one use case you can tell me. Audience
right
can
now.
also keep on guessing in the chat. Audience can, if anyone in the audience knows, they can also tell us. I'm just
I
looking
think
at the
it's
chat.
used in a dictionary,
Okay.
or like some like in code editors there is autocomplete thing. So when we write the first string, it displays all the current
Yeah,
completions that are there.
correct. Auto suggest using try.
Yeah.
Correct. Mukherjee is correct. Auto autocomplete. Okay, so you can keep on explaining while you are writing the code.
Yeah. So basically, what has next does is checks if the current next character exists in the current node, and if it doesn't, it returns a false. And here we're going to basically retrieve the. Okay, we can take references here. I think set EOS. This is going to be false. We're not going to set it false anyways. Also, we're going to make everything public. Okay, references here. What get next does is basically fetches if there is a current, if the current node has this character. If it doesn't have this character, it first creates this node. So let's
Mhm.
say it has c minus a. It will
So
create a new
basically, you are
node.
performing the insertion operation.
Yeah, get next. No, it kind of, if there's the node doesn't exist, then it inserts, or else it returns the node which is already existing.
So this function you are writing for inserting each and every word, na?
Yeah, but it'll also use it to get the words one by one. So I don't have to write an external function for that. It can accomplish both. So return. Let's see. Let's try node. This is, suppose, let's call the root, and this will be a dummy node, and we're also going to have a head. I'm going to iterate through each string one by one. I'm going to check if head. I'm not going to check, we're just going to get the next. Who's head dot get next.
Guys, he's efficiently coding tries almost. So you can hit the like button for him, and let's see what happens in the next 10 minutes. So what are you trying to do? First of all, I think you are trying to insert all the
I'm inserting
nodes,
each character one by one into the try.
each character. Okay,
Yeah, each
of
character.
a particular string.
Yeah, yeah.
Okay.
And after the string is ended, I'm just going to set this as set EOF. This is basically the end of word. I've written this correctly. Okay. I think this
So you
fixes
are
the try.
indicating that okay, at this particular string, the word is ending.
Okay. This is the basic try structure. Now I want to also keep count of the number of strings that are currently under a node. So I'm going to include that in a variable. Let's say count. Initially count is 0. And whenever we are creating a new node, that means a new word is being inserted, then we increase the current count. Let's know. Let me make sure. Uh, we can include it outside only. So include head of count. Firstly, set head equals to root, and then we are going to increment the count variable by 1 since we are including one word, and each time a new node is processed we're also increment this by 1. Okay. Yeah, let's go. Now this is the
Okay, so
insertion part done.
basically, when you are building the try, so what you are doing is for a particular node, you are saying that how many words are having that particular word, right? How many words are crossing that
Yeah,
particular path?
yeah.
And if it has just like when will you add? When will you say that okay, you can add it?
Sorry.
Let's say for Z, right? Let's say for Z, what will happen? Let's say for Z, when you're having zebra, so your try is, let's suppose your try is built. So you are saying that when your try is built, so when you will have zebra Z, okay, so
Yeah,
Z is
here it will
just having
first
the
check.
frequency as 1.
Here the first check has next if it has already Z or not. If it already has Z, then it will just return the next node. Won't create a next node. But if it doesn't has the Z, then it returns like creates a new node and returns that. And the count function is basically doing here as soon as we like encounter a new node in the sense like as a like in a new word a new character is being inserted. So in that case we're going to increment the current node's value by 1. Okay, so the n is this. Okay, got it. That was again. Okay, let's say the current string which you're going to insert. Okay, we can just push back this. First, we'll do the same thing and we check. Okay, we initialize head again. Head equals root. I retrieve the first head. Okay, this would be arrow operator since we're operating with pointers. This would be get next. Get next. And we add this current character to this string. And then we check if head dot count is equals to 1. Yeah. Then basically we break out of this. And we've got our current node and we push this in this back. And at the end we just return the answer.
Can you tell us what happened with zebra? Let's say your try was built. What happened with zebra then?
I'll just run you through this again. I'll fix the compilation errors first.
You can fix it.
Try not. Okay, this is a typo here. 49. What is this problem? Okay, I'll terminate this class. 111. Okay, let's see if this is running or not. Compilation error, try node. Okay, typos. 3. So I think it's going to problem with referencing. Just copy the strings here. Okay, so this version of C++ still doesn't support for each loops, I think. Okay, this is not an array, so I have to manually index through it. Okay. arrow operator. Okay, looks like it's working. So do you want me to try run this for Zebra?
You can try to submit it if it's working. We have less time.
Okay.
If it's working for the samples, you can submit it.
Okay.
Perfect. Perfect. Yeah, you can just quickly explain in 2 or 3 minutes what you did.
Okay, great. So for this Zebra, let's say we have taken Zebra. So I think it would be better to like draw an like explain. Can I draw this because try
Uh,
needs the
we
tree
have a
structure.
we have a constraint of time, so I'll explain on behalf of you. So basically, what he's
Okay,
trying to do
sure.
is he has built the try data structure. Now for this, the prerequisite is that you should know the try. Now what he has said, you are using counter, right? So what he
Yeah.
has done is like let's say dog was there. So if inside the try, like uh, for the dog for the node D, that is from the root, there is a node D. So that will be updated 3 times. Its counter will be 3 times, right, Jagreet? You are doing this now.
Yeah. Yeah.
Its counter for you will be 3. So he's trying to iterate. So when he iterates D, so dog, when he goes for dog, so he sees that okay, D is having 3 frequencies, so it is common with 3 words, 3 different words, so he cannot use it. Then he goes to O is having the frequency as 2, so he cannot use it. Then he goes to G, okay, for dog, he goes to the next character. So for G, when he goes to G, then the correct frequency I think is 1, right? So in
Yeah.
that case, you are updating your string to dog. Okay. After that, let's say he has zebra. So for he goes to z, then z has the frequency as 1 itself. So he immediately stores it because he says that okay, if z is 1, so that z is just common with one string, so it's unique. So you will simply store it. If you talk about dove, so he goes to d, the frequency is 3. So that's why what he's doing is if the frequency is 3, so he'll say then no, he cannot do it. If he goes to o, then I think o is having the frequency as 2. So O is having the frequency. O is common in 2 words, that is dog and dove. So he'll not use it. He so he has up till now he has stored do in the answer, I think. Then he goes down and he goes to v. So v is having the frequency as 1 only. So he stores dov. This is what you're doing.
Yeah.
Okay. So this was the code. So now Jagreet, like it was a great session. Like can you share the experience with us? Like how was it? Then I'll share my feedback if you want. How was the
Right.
experience?
So it was a great experience. Like normally the what coders do is they don't have this habit of like coding and explaining the lines they're writing. So that also happened with me. So the mind has to be in two places. Like one, you have to explain the code that you're writing, and also like you have to write the code that is correct. So that kind of like it's distracting at some point. But that's what interview is about. So this mock interview really helped me like counter that issue. Like that's really helpful for that.
Okay, and one more thing, I think that you could have implemented the word wrap. You were able to think about DP and taking,
Yeah,
not
yeah,
taking
yeah,
things like that. It's very, very similar to the knapsack basic parent problem.
yeah,
So I
yeah,
think you could have implemented it. There were some issues. I think basically you were not thinking much before writing the code sometimes. So that is why
yeah.
overall your flow was not that good. But overall, like if I'll share my feedback, so you were really good. Your implementation skills are also good, and like since you said that your final year I think has just started, so you will be getting very good placements going forward, that's for sure. Very good
Let's
on
see.
campus
Let's
or
see.
off campus placement. So all the best for that. I really liked interviewing you, that's why I had taken two hard problems. So you almost solved two hard problems in an hour. So you just had like I think initially it was tough solving it online in front of 200 people
Yeah,
watching you. So it you have that peer pressure, but you still managed it almost. Word wrap, I think you almost did it. I know that you could have done it. You just needed 5 more minutes for it to figure out. So that was really great. And thank you, Jagreet, for taking your time and being there for the mock interview. Thank you for volunteering. And I hope that you like the experience of taking this mock interview at GFG.
definitely, definitely.
Okay. So thank you, and we'll see you some other time, maybe for some other mock interview if you will like.
Sure,
So
sure.
thank you, Jagreet. So bye, actually. So now, hi everyone. So thank you everyone for joining in. I hope that you liked this particular mock interview. We had Jagreet, so I tried to ask him some good questions, two hard questions, and he almost coded them up. So make sure to hit the like button before we go. Make sure to hit the like button, and if you did like this session, so make sure to give us a +1 in the chat. Okay, I'm just here for 30 seconds more, so all of you can just give a +1 in the chat if you like today's session. the questions that we took, like both were hard level questions asked in some good product based companies that we aspire for, and they were not the generic question that we usually do. So a quick +1 in the chat and hit the like button, guys. I'm just waiting here for 30 seconds more, then I'll end this stream. Okay, I hope that you liked today's session. Jagreet was really good in terms of coding. I hope that you learned that, okay, when you get stuck, even then you can come back and do the second question, right? So these things you can learn from these kind of mock interviews. The questions, as you know, were disclosed to him right now only. So thank you everyone for joining in, and make sure to hit the, in case after this video is over, so make sure to comment down helpful or something. If you found this to be useful, then you can comment useful after this particular stream is over. And if you want to give the mock interviews, you can fill the form that's given down in the comment description of this video. Thank you everyone for joining, and I'll see you in the next mock interview. Till then, take care, goodbye, and happy coding.